So now you've seen a little bit of how we're going to pipeline a MIPS processor. Let's talk more detail about what pipelining is, and we'll do that by looking at some examples. So the first example we're going to look at is doing laundry. And this is a fine example. It's taken from the book, so you can read about it there too. So we've got 4 activities to do laundry. We need to wash the laundry, dry the laundry, fold the laundry, and then put it away. And each of these takes 1 hour. So the question we want to ask is, how long will it take us to do 4 loads of laundry? Well, if we do them in the sort of straightforward serial way, one step after each other, it's going to be washing and drying and folding and putting away, so 1 hour each to take us 4 hours. 4 loads are going to be 4 hours per load. It's going to be 16 hours total. And we can take a look at that, and here's the schedule. We do our first load of laundry, then our second, third, and fourth. Now to understand what's going on here, let's look at the resources we're using. So here are the resources we're using over time. So for the first load of laundry, we use each of the washer, the dryer, folding, and the closet once, one after each other, and we do the same for the other ones. Now a question, what percentage of our resources are we using here? Well, here's the total amount of resources we have, looking at every resource in every hour. And as you can see from this, we're only using 25%. So we're using 1 of each of these things at every time. The other 3 are idle. So the question here is, how can pipelining help? How can we use pipelining to do this more efficiently? So now let's take a look at doing pipelined laundry. So we're going to overlap the activities, and we're going to ask the same question. How long does it take us to do 4 loads? So here's the schedule we had before, and instead of doing this, we're going to overlap them. So we're going to start the second load after we've started the first load, but before it's finished. And the same thing for the third and fourth loads. So now we've got our first load. We start the second load as soon as the washing machine is free. Start the third load as soon as the washing machine is free, etc., all the way through. Now let's take a look at our resources. So here are our resources, and what you see is we're using them much more efficiently. Here's the quarter that we were using before, but now at the same time that we're doing the first load, we're going to use an idle resource to start the second load. Then in the third hour, we're going to use another idle resource to start the third load and continue with the second load while we're continuing with the first load, etc. And so what we have is we're going to have much more efficient use of our resources. So if we can do 4 loads at once, we can use all the resources at the same time. And that's what you see here. Here we're using the washer for the fourth load, the dryer for the third load, folding the second load, and using the closet for the first load. So pipelining here helps us by letting us use all of our resources at the same time for different activities. So we did 4 loads in 7 hours, but each load still took 4 hours. So this is 7 hours versus 16 hours. This is 2.3 times faster. So we sped up by over 2 times. So here's a question to think about. How many people would you need to do all 4 activities at the same time? Well, you're going to need 4 people. We're doing 4 things at once, so if we needed 1 person before, we're now going to need 4 people. This is equivalent to needing control logic to do 4 instructions at once in the processor. So remember, we designed control logic to look at each instruction. Now if we're going to pipeline our processor, we're going to need more control logic to take care of each instruction at the same time. Another example is producing cars. So Henry Ford is famous for this, for doing pipeline production, an assembly line in a factory. And here you can see a bunch of cars being assembled. They're all in a line, and at each stage, a car gets another part. So if we look at doing serial car assembly, first we're going to put down the base of the car, then we're going to attach the motor, add some wheels, put on the body. We've produced a car. Each stage here takes an hour. Then we can do another car. First we do the bottom, then we put on the engine, the wheels, and the body, and now we've got 2 cars. So if we do this one after each other, you can do 1 car in 4 hours. Let's take a look at what we can get if we pipeline it. So here's our pipeline, here's our conveyor belt, and in the first stage of the pipeline we're going to put together the base of the car. Then we're going to move the car over to the second stage where we're going to attach the motor. And at the same time that we're attaching the motor, we're going to start the base of the next car. Then we move them both over. Now the second car is going to get a motor, and the first car gets wheels, and we start a third car. And we keep doing this until we're all the way through our pipeline. Now at this point here, our pipeline is full. Every stage of our pipeline is doing something. They're all doing different things, but they're all working on different cars. So right here we're getting great efficiency. Every pipeline stage is working on a different piece of work. Finally, we finish the first car, and we go and start the fifth car. So what do we get here? Well, pipelined, we get 1 car every hour. So this is much more efficient than what we had before, where we were only getting 1 car every 4 hours. So here's a question. What happens to your efficiency if you can't keep the pipeline full? Well, it's going to go down. If the pipeline isn't full, we're not using all of our resources, so we're less efficient. So it's very important to keep the pipeline full if you're going to make a pipeline effective. So here's a question about pipelining performance. If we pipeline a car production by dividing up into 4 steps that each take a quarter as long, how much of a speed up do we get? Well, we can run 4 times faster. When the pipeline is full, we'll produce a new car every hour, which is 4 times faster than what we had with the serial production, where we produced 1 car every 4 hours. But it's important to keep in mind, it still takes 4 hours per car. It's just that on average, we produce 1 car every hour.